Welcome to our lesson on engineering drawing. We are going to have at the introduction to house or home plans. First and foremost, the owner makes a requisition. So he goes to an engineer, then they discuss. After discussing, those are issues like how many rooms, kitchen, bedroom, such like. Then the engineer takes the data. After taking the data, he prepares a document so that he's able to begin drawing. Now, before he begins to draw, he has to put on the details for a client. For example, here we have the name of the client. It's indicated here. The project, is it residential, commercial, and such like. And then site. The site is where the structure is going to be built. The details are also there. And then the date the construction is going to start. Then we have a scale here, 1 to 100, 1 to 2500. This is just an introduction. As we go ahead, we shall be able to see how the scale is normally developed. Then the consultants. The consultants are normally the engineers who normally undertake the project. So, before the project is done, the details here must be completed. After that, we have what we normally call a block plan. A block plan is nothing more than, much more than, the total land available for drawing our structure. So, the engineer must be given with a copy of the block so that he knows exactly how much land is available to be utilized. For example, from here, the block plan for this particular client was measuring 63 feet 6 inches. Once again, we shall look at the feet and the inches at a later date. And then that was the length. And then the width is 16 feet 3 inches. Once again, the notation, we shall see how it is done. Then number 2, where is this parcel of land located? The detail must also be given. So like this one, it's found around Nubia, Mosando Road. Then there is a Nubia Road going down like this. So that is the site plan. After that, the engineer goes now to the specifics. Now you see the specifics. Our block plan, remember, was measuring 63 feet 6 inches. So it is running from this point to that point. So that is our length. Now our width, the overall width from this point to that point is 16 feet 6 inches. And then the engineer now begins utilizing the spaces available. So from this, we have, this is one unit running like that. This is another unit running like that. This is another unit running like that. And that is referred to as the floor plan. And once again, the floor plan has a scale, like this is 1 to 100. Once again, we shall elaborate on that. And then the engineer now starts subdividing the rooms. For example, this is our bedroom, sitting room, store, and the kitchen. Likewise to this other one, sitting room, bedroom, kitchen, store. The other one is also sitting room, bedroom, store, and the kitchen. That is the floor plan. Now, once again, the rooms cannot be without walls. They must be subdivided. For example, if we look at the sitting room here, roughly it measures from this point to that point, that is 10 feet 0 inches. That is the bedroom. Likewise, the sitting room, 11 feet 0 inches, like that. So there is provision for the walls. For example, these ones are our walls all around. And once again, there are other metallic structures like windows, doors, and such like. So at a later date, we shall be able to know symbols, what they stand for. For example, around this region, we have a window. And around this region here, like that, we have a door entering these rooms. Another door here, and yet another door here. Then it goes right to the kitchen. So we have a kitchen. And then these symbols here, they stand for something we shall elaborate at a later date. And then we have the septic tank. So all the waste waters that will be coming from the house will be channeled to the septic tank through what we call a manhole. A manhole is a central collection point for water, dirty water that goes to our septic tank. Now, having heard that background, we have C1C. It's like somebody is chopping the whole of this part. Now, when you chop the whole of this part, its cross-section is going to appear like this. This is our section now, section C1C. Remember, when we chop that part, this is how it appears. Now, from the roof level, you can see these structures there like that. These are called trusses. They support the roof. Technically, you'll come to learn how they are drawn. And then, now, this part is our roof. From this part to this part is our wallings, our walls. And then from this part to this part is called ground level. Now, once again, the ground level, you have to dig it deeper enough so that you have proper concrete poured in there, like 9-inch thick foundation, 6-inch by 27-inch concrete footing. Later on, we shall look at the concrete footing. What does it mean? So, when we cut this cross section here, down below, we have the ground level. And then, now the ground level here, we have hardcore and concrete floor. So here we have a floor and a concrete slab. Other details that are normally provided are details like purlins or struts, tie beam, rafters, and 3-inch by 2-inch and 2-inch by 2-inch joints. So these are basically pieces of timber that are normally used to construct our roof. So we must also be given that information in the plan so that when it is used, it does not cause confusion. And once again, we have 8-inch by 1-inch fascia board. Now, somebody would ask, why are we using inches and feet? Remember, we are a colony of the British, so the inches are as a result of inheritance. So we inherited the inches from the British. Likewise, we have SI unit, where SI means Standard International Units. Once again, after drawing After having that basic on groundwork, now we move to wallings and the roofs. From here, you can see the front elevation. These are the doors, and windows like that. So these are the standard symbols that are normally used to represent windows unless otherwise specified. So that is the front elevation. And then we have what we call rear elevation. Rear elevation means the back, when you are looking at it from the back. So from the back, you can easily see chimneys. This is a chimney, a symbol for a chimney. And this other one here is a symbol for a chimney. And then we have a roof. So this is our roof. Yeah. That is the rear elevation and front elevation. So this is the front elevation. This is the back elevation when you are looking from the back. And then again, we have what we call left side view when you are looking from the left. So you can see this chimney from the left side view. This is our roof here, and these are our pressure vents, normally indicated by PV, pressure vents. So this is our left side. And once again, when you view it from the right side, seeing the vent is now here on your right, and the rest of the details. Now once again, having had that introduction, we look at the site plan. We have already looked at the site plan. Now we look at other accessories, schedule of doors and frames. The details cannot be complete unless or until we have the windows. So the details are written here. Serial number 1, we have door 1, door 2, door 3. Now the height and width 6 inches, 6 feet 9 inches. The width type 3 feet 0 inches. Door number 2 is 6 feet 9 inches height, and the width is 3 feet 0 inches. See, one like that, those are feet. When there are two like that, those are inches. Those ones are windows. Now, the number of windows required, the number of doors required, door 1, number required are 7 for the whole structure. So you can count 1 door, 2 door, 3 doors, 4 doors, 5 doors. And then there is a last column for remark. The remark here comes in when there are changes to our plan so that it warrants changes in the doors and such like. And then door number 2, these are the specification for height. These are the specification for width. The type now is called flush door. These are normally office doors, flush doors. And then door number 3, also we have 6 feet 9 inches like that height. Width is 3 feet 0 inches. And then the type of door is a T door or TNG door. This is normally another type of door. So we have various types of doors. We have the T door, flush door, TNG door, and the T door. Once again, if there is a challenge, remarks must be put there. And then we have windows. Windows are normally steel structures that are normally done by a welder. On top here, T door, flush door, and such likes are normally handled by carpenters. So all wooden structures are normally handled by carpenters. And then steel structures like windows and such like are normally handled by a welder. A welder is a person who does welding fabrication. He welds things using electricity. So window 1, we have 3 feet 6 inches by 3 feet 3 3/4 inches, and that type is steel. The number required is 3. We have window 2 also. The number required, the size of the window is 3 feet 0 inches by 3 feet 0 inches. Steel also, and then the number required are 5. We have likewise window 3 and window 4. So this column here is what constitutes accessories. So the engineer must make a fairly accurate information as pertains the accessories required. So that one also forms part of what we call quotation. So the quotation contains the details of what is required, the material from which it is going to be constructed, the number required, the size, the cost, and any other requirements. So that one is the single most important information that the engineer ought to give to the client. And then we have notes. Notes normally assist all and sundry, that is technicians, carpenters, all these people who are involved in working, to be able to get exactly what is required, when and why. So we have the pressure vent. Now the pressure vent is to be placed above all openings. Remember, pressure vents are for circulation of fresh air in the house. So they must be put above all openings. Now openings could be windows, that could be doors and such like. And then we have the DPC to be laid underneath all walls. Now the DPC means damp proof course. Now the damp proof course is normally laid underneath all walls, which means from the foundation we have to put our damp proof course so that we don't have water seeping from the ground upward through osmosis. So this one is also very important when undertaking constructions. And then all measurements to be checked and any discrepancy to be reported to the undersigned. So these are the consultants. In case of any challenge, some measurements is not tallying according to the plan, changes must be made so that we have accurate information. And again, accurate information is important so that we can avoid things like falling structures that the ratio has not been properly put. And then we have an approval. So it is normally approved by the engineer and a rubber stamp put. Now, when we look carefully at our plan, there are thick lines like this one, thick lines like this one here, and we have thin lines like that one, thin lines. They also have a purpose they play. So this one was just an overview. We were having to look at overall how structures are normally made, how they are drawn, and why they are drawn. So standardization is very important so that structures are properly done. A proper house or a proper structure begins from proper design, proper drawings, accurate drawings, so that we don't encounter problems or challenges of falling houses and such like. So this one is meant for technical. Now as we advance, we shall look at the lines. What do they mean? The symbols, the scales. We shall cover that into details during our next lesson. Thank you.